An atom containing central nucleus with positive charge and orbits. These orbits containing electrons which are negatively charged. These electrons are attracted towards the nucleus due to the force of attraction between the electrons and nucleus. But here the repulsions exist between these electrons. These inner electrons repulse these outer electrons. These outer electrons. These repulsions are known as shielding effect or screening effect. And here there is a force of attraction between nucleus and electrons. These electrons are attracted towards the nucleus. These electrons are attracted towards the nucleus due to force of attraction between the electrons and nucleus. This force of attraction is known as effective nuclear charge. But here the electrons are bound towards the nucleus because the effective nuclear charge Z effective is greater than shielding effect or screening effect. If we want to know the Z effective of the electrons, if we want to know the Z effective of these outer electrons, we have to know the shielding effect or screening effect sigma value of these inner electrons. By knowing this shielding or screening effect of inner electrons, we can calculate Z effective or effective nuclear charge of these electrons. Suppose if we want to know the Z effective of this electron, we have to calculate the shielding or screening effect of these inner electrons. Suppose if we want to know the shielding or screening effect of these electrons, we have to calculate the shielding or screening effect which are inner side towards these electrons. From this we can know that only by calculating the shielding or screening effect of inner electrons, we can find Z effective or effective nuclear charge. When we are calculating the Z effective of these electron, this outer electron will not participate in screening or shielding effect. This electron does not undergo. This outer electron does not undergo any repulsions. That's why we won't calculate the shielding or screening effect of this electron. Only we calculate the screening or shielding effect of these inner electrons. From this we can understand that there exists a force of attraction between the electron and nucleus due to effective nuclear charge. This effective nuclear charge is greater than shielding and screening effect. That's why these electrons are bound towards the nucleus and electron repulsion exists here. This is known as screening or shielding effect. We can know the Z effective when we know about this shielding or screening effect. When we know this shielding effect or screening effect, we can calculate the shielding or screening effect of these electrons from the sigma value. We have to remember this rule, Afebo principle. According to this principle, lowest energy levels are filled first. The electrons are filled first in lowest energy levels. That's why we arrange these in groups 1s2, 2s2, 2p6 in one group, 3s2, 3p6 in one group, 3d10 in one group. According to the n+1 rule, we arrange these as groups. According to this principle, we fill electrons first in lowest energy levels. Now the sigma values for ns and np. For ns and np, sigma values are when the test electron is present in that is the electron present in the outer orbitals, the electron which is present in the outer orbitals. When we are calculating the Z effective of the outer electron which is present in Ns and Np, the sigma values are 0.35. N-1 shielding electrons values are 0.85 and N-2 shielding electron values are 1.00. That the electron contributes 0.85, 0.35 and 1.00 for Ns and Np sigma values. When the test electron, that is the Z effective of the electron which we are calculating, is present in Nd and Nf, contributes sigma value of 0.35 and N-1 and N-2 shielding electrons contributes, that is these inner electrons contributes 1.00. Example, zinc having an atomic number 30. Now we have to arrange these electronic configuration in groups, that is 1s2, 2s2, 2p6, 2p6, 3s2, 3p6, 3d10 and 4s2. According to Haber principle, we have to arrange these. Now we have to calculate the effective nuclear charge of outer electron, that is valence electrons, 4s2. We have to calculate the effective nuclear charge of only one electron. This 4s2 s orbital containing two electrons. We have to calculate the effective nuclear charge of these electrons. We only consider these inner electrons, that is 4s1, 10, 6, 2, 6, 2, 2. We calculate the shielding effect of these all electrons. Now this electron which is present in Ns and Np, the sigma values are 0.35, that is the 4s containing one electron. This electron contributes 1 into 0.35 and the inner electrons of N-1, 4, this is the N value, and N-1 that is equal to 3, this contributes the 10 electrons, 10, 6, 2. This is N-1 level. Total 18 electrons. These 18 electrons contribute 18 into 0.85, that is N-1 contributes the shielding electrons of N-1 contributes 0.85, that is 0.85, and N-2 level, that is 2 electrons contributes these 6, 7, 8, these 8 electrons and these 2 electrons, that is 1s2. This 1s1, it is not N-2, but after N-2 the electrons which are present in 1s2 also contributes 1.00, that is 1.00 into 10. Now we can have a value 10.30 plus 10.00 equal to 25.65. Now we can get sigma value equal to the shielding constant value equal to 25.65. From this value we can calculate Z effective. Z effective equal to Z minus sigma, Z equal to 30 minus 25.65, that is Z effective equal to 4.35. Now let us take an example of scandium in atomic number equal to 21. Now we should arrange according to the energy levels, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1 and 4s2. In question, if it is asked that effective nuclear charge of 3d1 electron, so we have to calculate the shielding effect of these inner electrons, but we should not consider these 4s2 electrons. These are outer electrons. These electrons does not participate in repulsions, so we should not find the shielding effect of these electrons. Now we have to calculate the 3d1 electron Z effective. We have already learned that the Z effective of these electrons can be calculated by using sigma values, that is shielding effects. The NF and ND electrons contribute sigma equal to 0.35, and N-1 and N-2 levels of electrons contribute 1.00. That is the 3d1 electron. We have to calculate the electron shielding effect of, that is shielding effect of 3d1 electron. Now we have to calculate the shielding effect of these inner electrons. The electron is present in 3d1, so the sigma values are 0.35, and N-1, N-2 levels have 1.00. So now this is n electrons, here 3. So these electrons belong to n level, and these electrons belong to n-1 level, and it is n-2 level. Here in 3D, here ND and NF contributes sigma of 0.35 for ND and NF levels, and and N-2 levels, and all other levels of inner electrons contribute 1.00. So now this 3s2 and 3p6 containing 6, 7, 8 electrons contribute 8 into 0.35, plus these n-1 electrons contribute 6, 7, 8 electrons contribute 8 into 1.00, plus 2 electrons contribute 1.00. Now calculate the sigma values and find Z effect. Now another example is neon. Its atomic number equal to 10. Now arrange the electronic configuration according to their groups, 1s2, 2s2, 2p6. Now we have to find the Z effective of valence electron. Only valence electron. These 2p6 electrons contain one outer electron, that is 6th electron. We have to find the Z effective of the 6th electron. Now these 5 electrons other than the 6th electron contribute 5 into 0.35 plus 2 into 0.35 of 1s2 plus 0.85 into 2 electrons of 1s2. Now the sigma value, that is shielding effect, is equal to 4.15. We know that the NS and NP have the sigma values of 0.35, and N-1 have 0.85, and N-2 have 1.00, and ND and NF have sigma of 0.35, and N-1 and left other inner electrons have 1.00. So here 2s2 belongs to ns, it is ns orbital, so 0.35, and it is n-1 orbital, so 0.85 into 2. Z effective means we always calculate the shielding effect of outer electron, that is valence electron. Let us do another example, sodium. Its atomic number equal to 11. And arrange the electronic configuration according to the groups, that is according to Lefebvre principle, 1s2, 2s2, 2p6 and 3s1. We have to calculate the Z effective of outermost electron, that is valence electron, that is 3s1. We have to calculate the Z effective of this 3s1 electron. So this is n-1 electrons, shielding electrons, and it is n-2 shielding electrons. n-2 shielding electrons, a total 6, 7, 8. 8 electrons, 8 into 0.85 plus n-2 electrons, 2 into 1.00, 6.80 plus 2.00, the sigma value. When we are calculating the sigma value, we always leave this outer electron, the electron, this electron, we always leave this outer electron. If it is 3s2, we leave one electron, the electron which in the electron is lived, and the electron and another electron, that is 3s1. We will calculate this 3s1 electrons shielding effect by 1 into 0.35. We won't calculate the shielding effect of this electron because we are calculating the Z effective of these electrons. These all inner electrons are shielded by this electron. That's why we are calculating this shielding effect of these inner electrons. That's why we won't calculate the shielding effect of this electron, because we are calculating the Z effective of these electrons. That's why sigma value equal to 1.60 plus 2.00. Now that is 7.2.6.80. Sigma equal to 8.80. Now from this we can calculate the Z effective of, sodium, that is 11 minus 8.80. By taking different examples, calculate yourself, try yourself.